Hello. Let me first introduce myself. I'm Prita Falenshia from the 12th Science from the school MB3 or Mutiara Bangsa 3. We are going to talk about derivative for the subject Advanced Math. The content of this presentation is going to be some opening, history of topic, case of application, problem solving, and closing. We will start with the opening. By the opening, we're going to understand what is derivative. Derivative is a measurement of how function changes as it goes along changes in value. The process of finding the descent is called differentiation. Differential or derivative is the first basic of calculus. Calculus is the mathematical language that explains the phenomenon of changes in certain functions. Calculus plays an important role in various things, be it differential or integral or in other sciences, for example, physics, engineering, economics, and others. For example, in mechanism, differential allows us to find the rate of change of velocity with respect to time, which is acceleration. A brief history to the calculus is divided into several phases. Namely, in phase 1, the idea of the basic theorem of calculus was developed by Eudoxus from the 408 to 325 SM and Archimedes from 287 to 212 SM. By learning how to determine the area of an irregular building, this concept is what we apply in determining the area bounded by the curve. For the phase 2, Leibniz and Newton researched the calculus we are studying today, which is Leibniz studied and researched integrals, while Newton focused on more derivative, which we will study now. For phase 3, in the 19th century, many scientists analyzed the calculus. These scientists include Riemann, Bolzano, Dirichlet, etc. For the phase 4, Canterbury and Lebesgue found this set theory. Therefore, the calculus we study nowadays are the thoughts of Leibniz and Newton, which is about differentiation and integral. And here are the cases of Archimedes and Newton. Before studying derivatives, it's a good idea to understand about these materials first. There are types of numbers, function graphs, algebra, absolute value, and trigonometry. The uses of derivative in everyday life are making building constructions. For example, to find the reaction of placement of the construction to overstack beams with a uniform load. It is also used to calculate multiple beams construction with triangular loads and much more. For the second example, we are going to use derivative to make transportation models. For example, the manufacture of aircraft. In its design, aircraft must pay attention to the shape and materials used. This shape will also affect the calculation so that the aircraft does not experience problems when flying in the air. One of these calculations also involves the derivative as the formulas used. For the example 3, we are going to talk about aviation. This derivative is used to calculate the acceleration and distance experienced by the aircraft so that later the aircraft will not lose its navigation outside the airport tower. Because as we know, the speed possessed by the aircraft is affected by time and can be lower so as to produce the acceleration of the aircraft itself. For the example 4, we are going to talk about the place measurement. For example, we have a plot of land built a farm. Now, to determine the maximum shape, we can make a model by utilizing derivatives so that we can get the maximum area and can accommodate more livestock. For the last example, we are going to talk about business. We can predict that our production does not suffer losses or that we do not reach the minimum value in the production function. And now we are going to solve a problem using the theory for businesses. Let's say we have a mom who is able to sell a product of 2,000 minus 10x units per month with the selling price of each unit x thousand rupiahs. The total cost incurred in each month is 25,000 plus 400x 1,000 rupiahs. Mind you, it is in 1,000 rupiahs. In order to get maximum profit, how much is the selling price per unit and the maximum profit? Before answering, I'm going to let you know some notes I have written here, which are XS, which is the selling price as shown here, and the PX is the profit, which is shown here, and K is in thousands. Okay, now we are going to start finding the selling price. Oh, I forgot to put down a X here behind the 10. So we are going to time the units by rupiahs because we are going to find the average salary of each month. So we are going to multiply the X into 2,000 and the X to minus 10X. Then the result will be 10X squared plus 2,000XK. Remind you, K is 1,000. And the total cost of our average salary is 25,000 plus 400XK. To find the profit, we're going to minus the selling price to the total cost. Why? Because we imagine, if you're going to sell something for 1,000 and your cost is 800, your profit will be 200, right? So that's what we apply here. We are going to minus the selling price, which is here, to the total cost, which is here. And then you're going to sum all of it. Then we get a function of minus 10x squared plus 1,600x minus 25,000k. And to find the selling price, which is one of the questions, we are going to differentiate the px, the function px, which is going to be like this. The squared is going down and time the minus 10x. Resulting, we have a minus 20x, and the derivative of our 1,600x is 1,600, and the derivative of only numbers is 0 because they have no variables. When it looks like this, we can move the minus 20x to the left side, and then we divide both sides with 20. So we'll have x equals to 1,600 plus 20 equals to 80k. We are going to add k because we have a k here, okay? And to find the maximum profit, which is the second question, we are going to substitute our x into 80. So substituting the x to 80, we're going to have this function, which is minus 10 times 80 squared plus 1,600 times 80 this is this, minus 64,000 plus 128,000 plus 25,000 K, and if we sum all of this, it will be 39,000 K, and K is x 0.000, which is 8,000. So we're going to time this with 1,000 and we get 39 million rupiah. So for the conclusion of our presentation now is that derivative is a measurement of how function changes as it goes along changes in value. The calculus we study nowadays are the thoughts of Leibniz and Newton, which is about differentiation and integral. And the last but not least is derivative is used in many aspects. For example, businesses, constructions, transportation models, etc. And here are the sources I got these presentations for. Thanks to all of them, and we are done. You've reached the end of this presentation. Thank you, best regards, Prita Falenshia. Have a nice day. Bye-bye.